Hello, guys. Welcome to Ramta Solutions. Welcome to your lesson on atomic mass and the mole. So, this is still quantitative aspects of chemical change. Okay. So, in this video, we are going to be looking at your atomic mass, your mole, Avogadro's number, molar mass, relating molar mass to mole, and we will also be having examples of all these. Okay, so let's not waste any time and begin with the atomic mass. Now, when it comes to the atomic mass, we are basically talking, I don't want to say the history, okay, but otherwise I will be saying we are basically talking the history. So one thing we know is that every atom, or rather, every element has its mass, right? That's the most important thing. Every element has its mass. Now, the history of the mass of each element has varied over the years. So today, because we're not going to look at thoroughly into the history today, as we look at it, these masses, right? So these masses, because we're now referring to all elements, so these masses are related to the mass of carbon 12. Okay, let me write that down. They are related to the mass of carbon 12. Okay, they are related to the mass of carbon 12. So basically, this carbon 12 is your standard mass. Okay, this carbon 12 is your standard mass, meaning that all other masses are determined based on this. Okay, let's say, for example, carbon 12. So this carbon 12, its mass is 12 grams. Let's look at, for example, magnesium. Magnesium, its mass is 24. What does that tell you? 24. So 24, this tells you that, it is, 24 grams. This means we have two carbon 12s, right? This means we have two carbon 12s, right? Two carbon 12s, right? When you have two carbon 12s, what does it mean? It means we have 2 times 12, which is 24 grams. Okay. Now, I will also take, how about I take titanium. Let me take titanium. Okay, titanium, it has, when you look at the periodic table, it has a mass of 48 grams. Okay, it has a mass of 48 grams. So what does this tell you? 48 grams. If we divide this 48 grams by 12, we are getting 4 carbon 12s, right? We are getting 4 carbon 12s, right? We are getting 4 carbon 12s. So basically, this is how the masses that you are seeing on your periodic table are determined. Okay, this is how the masses are determined. They were called atomic mass units, but because, science evolves, they no longer refer to them as atomic mass units, which sometimes you can see them being referred to as AMU. Today, the preferred name is relative atomic mass. Okay, today it is relative atomic mass. Okay, so let me say, today we prefer to say relative atomic mass. Okay, we prefer to say relative atomic mass, which some textbooks will define as AR. Okay, remember, instead of atomic mass units, in terms of instead of atomic mass unit, which was AMU. Okay, which was AMU. Let me not squeeze it. Which was AMU, atomic mass unit. Okay, so this is how the masses are determined in your periodic table. But now I want you to look at this. I want you to look at, for example, the mass of hydrogen. You know it. Your periodic table will say to you it's 1 gram per mole. So basically that tells you 1 gram. 1 gram, what does it say? You divide by 12 grams. Oh, so that means you have 1 over 12 carbon 12s. You have 1 over 12 carbon 12s. Do you see that? That tells you that this hydrogen is very, very small. Okay. All right. So remember, guys, the reason why they introduced atomic mass is because the masses of these elements were very, 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 very small. Okay, they were very, very small. Some textbooks will tell you that the mass of hydrogen is 1.6 times 10 to the negative 24. That's a very small number. So this is why they prefer to now introduce this relative atomic mass. Okay, because they didn't want to work with such small numbers. Okay, they didn't want to work with such small numbers. So carbon 12 is just a scale and nothing else. Okay. All right. So the mass that you are seeing on your periodic table, it's your relative atomic mass. Okay? It's your relative atomic mass. All right. All right. Perfect. So now let's look at the mole. Let's look at the mole. Before we start with the mole, I want you guys to tell me, what do you understand by the word dozen and what do you understand by the word pair? Whenever you see the word dozen, it means you have 12 similar things, isn't it? It means you have 12 similar things. When you have a pair, it means you have 2 similar things, right? So if I say a pair of, I want you to count. If I say a pair of calculators, what does it mean? It will mean that you have 2 calculators that are the same. Okay? And if I say you have a dozen of calculators, what does it mean? It will mean that you have 12 calculators. If you have a dozen, it means you have 12. So as you can see, whether you referring to elephants or whatever, the number does not change. Of course, the mass will be different. But when we talk of dozen elephants still mean 12 elephants. Dozen eggs still means 12 eggs. Right? Of course, the masses are different. Okay? The masses are different. Okay. So now because now we are now scientists. Of course we are. Don't worry, guys. Even in high school, you are still a scientist. All right. So because we are budding scientists, or we are scientists, we will say, now, what is a mole? Now, a mole, we should also call it I think we should also call it a unit. All right. It's also a unit. Okay. It's also a unit. Remember, dozen of elephants still means 12 elephants. Pair of elephants still means 2 elephants. All right. I know you prefer to say double. Double still means 2. Right. So when we are now referring to the mole. Okay. So the mole, it's also a unit, or is also a unit. However, when we use it, we use a mole because we want to know, let me write it down. We want to know how many particles are required for a reaction to take place. Okay, so let me say that. Want to know how many particles are required for a reaction to take place. Okay, for a reaction to take place. Okay, we want to know how many particles are required for a reaction to take place. So you see, you must underline how many. When you say how many, that means you are counting, right? That means you are counting. Okay, that means you are counting. So this therefore says to you that amount of substance, that a mole is an amount of a substance. Okay? So a mole is an amount of substance, because remember, I'm saying when you want to know how many particles are required, for example, for a reaction to take place, you want to know the amount of a substance. So this amount of a substance is your mole. Okay? It's your mole. Now the definition that you are going to use is this. The definition that you are going to use is this. A mole is an amount of substance having the same number of particles as there are atoms in 12 grams carbon 12. I'm going to write that down. Amount of a substance having the same number of particles as there are atoms in 12 gram carbon 12. Okay, so simply it's basically saying to you it is the amount of substance that contains the same number of particles as there are present in 12 grams carbon 12. Okay, remember we are saying this is the amount of substance that contains the same number of particles as there are present in 12 grams of carbon 12. Okay, all right, so this is your mole. The key word here is amount of substance, however extended by saying amount of substance having the same number of particles as there are atoms. If you don't want to say atoms, guys, you can just generalize it and say particles. Okay, and say particles. Okay, you can generalize it and say particles. Particles would include atoms, molecules, ions, and so on. Okay, so it is the amount of substance having the same number of particles as there are in 12 gram carbon 12. Okay, so maybe I can just remove this and say amount of substance having the same number of particles as there are in 12 gram carbon 12. How is that? Right. So I'm going to leave this and say, we will say it's okay. That makes sense, right? All right. Okay. So now, by now, you know that a dozen means 12 items. A pair means 2 items. But what does a mole represent? Okay, so what does a mole represent? We are getting there. So do not forget what I said as well. I had said before proceeding, I said it is also a unit, meaning you can say you have whatever mole of a substance. Okay. So now I want to tell you this. Before I proceed, I want to tell you this. A mole, or the mole is a big name. Okay? Is a big name. Remember, you said dozen is 12. You say kilo is 1,000. You say, what else do you say? Yeah, kilo is 1,000. Mega is, what is mega? Is mega a million? Yes, mega is a million. You see? Now, what is a mole? Just hold. So what is a mole? So when we talk of a mole, we said it's a big name. So what is a mole? A mole is, I want you to consider this, something that has this number of particles, 601, 204, 500. Let me count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 particles. Okay? A substance is, look at this number. I don't even know how to call it, but because we are doing science, we know that this number can be simplified to, I want you guys to count. We have 6. After 6, how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23. So we can say this number is 6,02 times 10 to the 23 particles. Okay, so 1 mole is 6,02 times 10 to the 23 particles. Okay, let's go. 1 mole is 6,02 times 10 to the 23 particles. All right, 1 mole is equal to 6,02 times 10 to the 23 particles. Right? Perfect. Now, we have covered the moles. So now, let us now quickly rush to Avogadro's number. We are quickly rushing to Avogadro's number. What is Avogadro's number? That's 6,02 times 10 to the 23 particles. That's Avogadro's number. Okay, that's Avogadro's number. Okay, that number is Avogadro's number. However, hold on, it is not necessarily this number on its own. So Avogadro's number, what is it? It is 6,02 times 10 to the 23 particles per mole. Okay, particles per mole. So I'm going to say to you, when we talk of a mole, we represent it with a small letter n. When we talk of Avogadro's number, we represent it with a capital letter N and a subscript A. Okay, and a subscript A. So, as you can see here, you have Avogadro's number. In other words, Avogadro's number is number of particles per mole. So, it has the formula N over this. So, what is this? Recall, this is basically number of moles. This is number of particles. And this, of course, is your Avogadro's number. Now, your Avogadro number is, it's a constant, okay? It's a constant, okay? Your Avogadro number is a constant, okay? All right. Let's see if we are leaving anything. All right, now we're going to the molar mass. Now we are going to the molar mass. Number 4, we are going to the molar mass. Is it okay if I go to, okay, remember what I have said, guys, before proceeding. I said Avogadro's number is 6,02 times 10 to the 23 particles per mole, right? Particles per mole. So if you want to know how many particles you have, you need to know the number of moles you are looking at. Okay, but we will do examples So stay tuned. Number 4, we are going to look at the atomic mass. Molar mass. We are going to look at the molar mass. Okay, we are going to look at the molar mass. Okay, so we have to define the molar mass. Okay, so basically, molar in chemistry, whenever you see the word molar, it basically means something per mole. So molar mass would mean a mass per mole. Okay, this is not the definition. So this must say to you, this is mass per mole. Okay, so you have what we refer to as your thingy, as your atomic mass unit or relative atomic mass. All right. So something you should know as well is this. This is basically when I give you the definition now, I'm going to give you a definition now. I'm going to say to you, the molar mass, when we talk of molar mass, we basically are talking mass, hear me out, mass of 1 mole of a substance. Okay. Mass of 1 mole of a substance. Okay. We are talking to mass of 1 mole of a substance. Okay. So you will be referring to molar mass, of course, talking about an element. And you will also be talking to, later, you are going to see it now, when you refer to that of a compound. Okay. Of a compound. Okay. So let's go. Now, we are saying that molar mass, normally we represent it with capital letter M. Okay, we represent it with capital letter M, or others call it master. Okay, others call it master. Okay, that's molar mass. Okay, remember it's 1 mole of a substance. Now this is measured in, gram per mole. It's measured in gram per mole. Remember I said whenever, depending on what you're going to do after school, if you're going to do any subject or any course related to chemistry, whenever you see molar, you must know that you have divided by mole. Okay, so molar mass, it means mass has been divided by mole. Okay, meaning it's mass per mole. As you can see, molar mass is divided in gram per mole. Let me say this, in gram per mole. Okay. All right. So now, what is this? I want you to note this. It is, maybe let me just say this, mass of an element. Okay, mass of an element is equal to its relative atomic mass. Is equal to its relative atomic mass. Okay, so in other words, when we refer to mass of an element, we are referring to that relative atomic mass that you find in the periodic table. Okay, that mass that you find in the periodic table, that's the mass of an element. Okay, so you can call it a molar mass of an element. Okay, all right. So when you have a compound, when you have a compound, remember, when you have a compound, that's basically where you say you have your more than one element making up that substance, right? Right? So when you have a compound, what do you then do? Okay, what do you do when you have a compound? When you have a compound, so your molar mass is referred to as the formula mass. So you will hear the word you will hear the word formula mass, molar mass being used interchangeably. It's okay. When you refer to an element, when you refer to an element, molar mass is simply the relative atomic mass. When you refer to a compound, you refer to it as the formula mass or molar mass. It does not matter. Either of them is correct. So when you look at it, when you have a compound, to get your formula mass, what do you do? To get your formula mass, you basically are going to add the relative atomic masses of the atoms. Okay, when you have a compound mass, molar mass is referred to as the, where's my pen now? Okay, it's referred to as the formula mass. So it is the addition of the relative atomic masses of atoms. It is the addition of the relative atomic masses of the atoms. Of the atoms making that, or of the atom that the compound consists of. Okay? Relative atomic masses of the atoms that I should say that the compound consists of. Yeah, because I use the compound, that the compound consists of. Okay, that the compound consists of. So this is your formula mass. It is not different to molar mass. However, you will see in examples to come what we are referring to. Okay, you will see in the examples to come what we are referring to. Okay, so we are done with molar mass. Let's then head to relating molar mass to mole. Is it number 5? Sure, it should be number 5. Relating molar mass to the mole. All right, to the mole. So we have said that molar mass is mass of 1 mole of a substance. So remember we said molar mass is basically gram per mole. Right? So we said molar mass is represented with the letter capital M. We know mass is represented with small letter m, and mole is represented with n. So normally this is what you find a lot, m over m. As you can see, it's cross multiplication. All right. So this is the formula that you are going to use. Okay. To remind yourself, you can use this triangle and say this is n. So what is n? N is m over capital N. So from this equation, what follows is that n, as you can see, is equal to m over mass over mass bar. If you're looking for mass, you will say mass is equal to n, which is number of moles, multiplied by molar mass. Again, if you're looking for m, let's say you are given mass and the number of moles. So if you're looking for the molar mass, you can say it is equal to mass over number of moles. Do you guys see that? So you can use this you can use this pyramid to help you understand this. Okay. All right. Now we are heading to examples. Let's see. Number 6. Number 6. The first example we are going to look at is this. Let's say okay. I think I'm going to try this one here. Let me see it. I'm going to say calculate the molar mass. Okay. Example 1, calculate the molar mass. So I'm going to say the molar mass of, I'm not sure which one to take, but I'm going to say the molar mass of A, iron, B, lithium, C, I'm going to take H2SO4, D, I'm going to take KOH. Okay, I'm going to take KOH. All right, so now let's start. Number 1, this is iron. It's an element on the periodic table. When you go to your periodic table, you will see iron with the letter Fe. Okay, you will see it with the symbol Fe. Okay, you will see it with the symbol Fe. So Mr. Fe, or molar mass of Fe, is, because this is an element, it is equal to the relative atomic mass unit. Your periodic table returns 56 grams per mole. Alright, it will be 56 grams per mole. Now, this is lithium. On your periodic table, it's represented as SLI. So this will be, its molar mass will be equal to the relative atomic mass unit on the periodic table, which is, what is lithium? It's 7 grams per mole. Okay, now let's look at this one here. We call it sulfuric acid. It's molar mass. Now, this is what we are referring to as a formula mass. Okay, this is what we are referring to as the formula mass. Okay, so remember we said we must add relative atomic masses of all atoms or elements making up this compound. So we have, as you can see, we have 2 carbon atoms, so it'll be 2 hydrogen atoms. So maybe let me say it's 2 hydrogen atoms or hydrogen elements, and we have 1 sulfur and 4 oxygens. Okay, you don't have to be writing it like this. I'm only writing it like this because I'm introducing this. Okay, so it's 2. What is the molar mass of hydrogen? It's 1. So it's 2 multiplied by 1. Sulfur, your periodic table says it's 32. There are 4 oxygens. Its molar mass is 16. Let's see what the answer is. 2 plus 32 plus, I believe it's 60 what? 64. Must be 64. Therefore, our answer is simply 98 grams per mole. Okay? Our answer is simply 98 grams per mole. Now, let's look at the molar mass of potassium hydroxide. The molar mass of potassium hydroxide will be, you have 1 potassium element or atom, so it's, look for its mass. What is its mass? The mass of potassium, it's 39, so it'll be 39. The mass of oxygen rather, is 16, and the mass of hydrogen is 1. All right, So what is this? This becomes 56 grams per mole. Okay, this becomes 56 grams per mole. Remember, whether you write it in this way or like this, it doesn't matter. Okay, doesn't matter. It's still the same. So this is your molar mass. So this question wanted us to calculate the molar mass, and this is the molar mass. Okay? All right. Perfect. Now, example 2, we are going to calculate the number of moles. We are going to calculate the number of moles for, let's say, A. We are given 10 grams of sodium sulfate and Na2SO4. B, we are given 40 grams of aluminium. Okay, so what do? We then say, okay, our solutions for A, we will say molar mass of sodium sulfate is 2 times, what is the mass of sodium sulfate or sodium? Sodium has 23 on the periodic table. Sulfate is 32. There are 4 oxygens, so it'll be 4 times 16. So what is the molar mass? Let's see. 46 plus 32 plus, I think this is 64. So our answer is 142 gram per mole. Right? Gram per mole. So what is the number of moles? N equals M over, right? So what is this? This is 10 over 142. What do we get? Our answer is simply 0.0704 mole of oil. Alright? 0.0704 mole. Okay. Now let's get to the number B. Number B, we need molar mass of aluminium. On our periodic table, it is 27 gram per mole. Now, what is the number of moles of aluminium? It'll be mass over molar mass, which is 27. 40. I think it was 40 over 27. Now, let's see. 40 over 27 is 1.48 mole. Okay. So, this is it, guys. I hope it makes sense. Now, we are going to the third example. Oh, what is happening now? Okay, example 3, we will say how many atoms are. Let's say how many atoms are in, what's going on? Okay. In, let's see, I will say, somehow there seemed to be a gem. Okay, in A, 1 mole of a substance, 1 mole of a substance. B, we will then look at 2 moles of calcium, 2 mole of calcium. And then C, we will then say in 24, oh boy, what's going on? In 24 grams of carbon, in 24 grams of carbon. And D, we will say in 24 grams of magnesium. Okay, in 24 grams of magnesium. So our solutions is this. By now, you recall that we said 1 mole of a substance is equivalent to 6,02 times 10 to the 23 particles. Particles could include atoms, ions, or anything. Okay? So, in this case, they say how many atoms are in 1 mole of a substance. For this one, the answer is simple. It's 6,2 times 10 to the 23 atoms. Alright? Now, in 2 moles of calcium, if you recall, you said 1 mole of a substance has 6,02 times 10 to the 23. Now, this time around, you will say this is 2 times 6,02 times 10 to the 23 atoms. What is this? This number will then be 6 times 6,02 on your calculator times 10 to the 23. This is 1,0. Sorry, it's 1,204 times 10 to the 24 atoms. Right? Atoms. Okay. I am aware that I'm not using the formula as yet. I am aware I'm not using that formula as yet. So, but we will be using it because we will have a video dedicated to this number of moles, or Avogadro's number. Okay? We'll have a video dedicated to it. So, now, we now have 24 grams of carbon. What we know that, remember that carbon-12 was basically our standard element, right, or our standard mass. And 1 carbon-12, right, 12 grams of carbon-12 was equivalent to 6,02 times 10 to the 23 atoms. But this time around, you have 24 grams. If you have 24 grams, that should mean that you have what? You have 2 moles, right? 24 grams would basically be 2 moles. So this therefore means for this one, it's the same as 2 moles of calcium. What is it? It is 1,2. It is 1,204 times 10 to the 23 atoms. All right? 10 to the 23 atoms. Okay. Lastly, 24 grams of magnesium. So magnesium, when you go to your periodic table, you will realize that the relative atomic mass of magnesium is roughly 24, right? So this will therefore tell you that this is basically 1 mole of magnesium. So 1 mole of a substance has how many particles? 1 mole of a substance has 6,02 times 10 to the 23 atoms. All right? Remember, 1 mole of a substance has 6,02 times 10 to the 23 particles. In this case, the question wants you to calculate number of atoms. So this is atoms. Instead of saying particles, you will simply say atoms. Okay. All right. So this is it. Now, let's head to the 4th example, which we are basically working. Let's see. So for the 4th example, we will say calculate the mass of, let's do this. Calculate the mass. I don't know, there seemed to be a gem on the system. Calculate the mass of 2,5 mole water. Okay, calculate the mass of 2,5 mole of water. So now, for this one, what you know is this. First thing first, you are looking for the mass, you are given the mole. You must find molar mass of water. Remember, water is H2O. What is it? It is 2 times a relative atomic mass of hydrogen is 1 and that of oxygen is 16. This therefore is 18 grams per mole, right? This is 18 grams per mole. So you recall N equals M over molar mass. So we are looking for the mass, therefore we will just say M equals N times molar mass. So this is 2,5 times 18. What's the answer? The answer is 45. So 2,5 mole of water is equivalent, or is 45 grams. Okay, is 45 grams. Remember guys, with this one, you can use the triangle and say N, M, and capital M. Okay, so this is it. I will see you next time. The next video that we are going to use is one that focuses strictly on Avogadro's number. So with that being said, it's a wrap. See you next time and bye-bye.